This is 7-1, Factors and Greatest Common Factors. In this section, we're going to be finding the prime factorization, which we use a factor tree to get, and we're going to also be calculating the greatest common factor. Let's look at some examples. For the prime factorization of 40, you build a factor tree. You can think of any two numbers that multiply to 40, like 4 and 10. This should be reviewed for you guys. 4 breaks down to 2 times 2. Make sure you're using multiplication. And 10 breaks down to 2 times 5. These are prime numbers, so I've circled them for you. And then you can rewrite this as 2 times 2 times 2 times 5, or in exponential form, which would be the best way to give me your answer, would be 2 to the third power times 5. And you can check to make sure that you have the right answer. 2 to the third is 8 times 5 is 40, what we started with. So that's good. Find the GCF of each pair of numbers. In order to find the GCF, you first want to list out the factor tree. So when I broke down 60, I ended up with 2 to the second times 3 times 5. Or 2 times 2 times 3 times 5. And for 24, I had 2 to the third times 3, or 2 times 2 times 2 times 3. So if we look to see what they had in common, they both have a 2, they both have another 2, and they both have a 3. So they have 2 squared times 3, or 2 times 2 times 3, which is 12. That is the greatest common factor. What you could do, if you can think of the shortcut, is you can keep the smallest of the exponents, so 2 to the second, and then the other one they had in common was 3 to the first, and so that's really what you're multiplying, 2 to the second times 3, which is right here. But it's just looking to see what they have in common. So if I break down 18, 18 is 9 and 2, and 9 is 3 and 3. So it's 2 times 3 times 3, or 2 times 3 squared. And 27 is 3 times 9, 3 times 3, and so that one is 3 times 3 times 3, or 3 squared. So, 3 cubed, sorry. But we keep the smaller of the two. So this one would have been 3 squared, and that one would have been 3 to the third. And so I would keep the 3 squared is what they had in common. 3 times 3, 3 times 3 is 9. That is the GCF. For monomials, it's the same thing. The 42, we start with the number 42, which would be like 6 times 7, and 6 is 2 times 3. And then you also have to break down the a's. Well, a to the third means a times a times a. So I'm just going to write that as 2 times 3 times 7 times a times a times a. And then for 18, a squared, break down the 18, 9 and 2. 9 is 3 and 3. So that would be 2 times 3 times 3 times, and then a squared is a times a. So let's see what they have in common. We have a 2 in common, we have a 3 in common, we have an a in common, and another a in common. And so therefore we have 2 times 3 times a, which is 6a squared. For 16, that would be 4 times 4, and 4 is 2 times 2, and the other 4 is 2 times 2. And then for the variables I have, it would be 2 times 2 times 2 times 2 times the variables x times y times z times z. And for 72, let's break that one down. We would have 9 times 8. Well, 8 is 4 and 2, and 4 is 2 and 2. So 2, 2, 2 from that, and 9 is 3 times 3. So I have 2 times 2 times 2 times 3 times 3 times, now the variables. I have an x, a y, and z cubed. So z times z times z. Let's see what we have in common. I'll actually highlight them to make it a little bit more clear. So I have a 2, another 2, another 2, an x, a y, and a z, and a z. So let's write that. We have 2 times 2 times 2 times x times y times z times z. Simplify that. 2 times 2 times 2 is 8 xy z squared.